You saw in the workflows that I include links to models, but you might wonder where I find those models, right? One of the sites is Hugging Face, but it is not the most beginner-friendly one. At the top, we have a Models tab, and here you can find a lot of models, but not all of them are diffusion models or used for generating images. Some are for video, some for audio, some for large language models, and many are not compatible with ComfyUI. Some require different interfaces to run, or they are so large that you cannot even run them on your computer. For example, I can sort them by text to image, and here you can see some popular ones like Qwen, ZImage, or even the Flux model. If I click on one of these, you will see that some models require you to sign in and accept certain terms. Each model has a license. Some are open source, some are free with conditions, and others are available only in certain countries. By default, you are on the model card. This is basically an info page about the model. On another tab, you have Files and Versions, where the files are usually available in different formats. Like in this example, and there are a few more files inside those folders. Let us go back to the home page. Here you can also search for a model if you know the name, or browse popular ones, like ZImage. Always check the tabs at the top to find more information about the models, since they can be quite large and you want to make sure you can actually run them on your system. I know this is a lot of information, but as I said before, I usually include the model link directly in the workflow, so you do not have to stress about it. Still, it is good to understand how models work and where they come from. Another site that is more beginner-friendly and better organized is the Civet AI website. The downside is that recently they removed access for some countries, like the UK. If you are from one of those countries, you will need a VPN to access it and download models. If you click on the Models tab, you can find all kinds of models for different interfaces like ComfyUI, ForgeUI, and others. Most of them are compatible with ComfyUI. On the right side, you have filters. These let you sort models by when they were added. You can also filter by model type. For example, checkpoints are the main AI models. You can also filter by LoRa or ControlNet, since we talked about those model types in previous chapters. Of course, you can also filter by base model, so you know what is compatible with your workflow. The first workflow we used was based on an SD 1.5 model, but I can also sort by other ones, like the FluxDev model, or an older one like SDXL. By the way, SDXL is newer than SD 1.5, and Flux is even newer than SDXL. So use these buttons to sort models. If you already know the name, you can just search for it. For example, I can search for Juggernaut. Here you can see multiple versions of that model based on different base models like SDXL or SD1. If I click on SD 1.5, I will only see those versions. If I click on the one that says Juggernaut, it opens the model info page. At the top, you can see different versions. We used the Reborn version, but you can try other versions as well. Below that, you have details about the model. It clearly says what type it is. It can be a checkpoint, a LoRa, or a checkpoint merge. In this case, it is a checkpoint merge, which means the main SD 1.5 model was mixed with other SD 1.5 models to combine the best parts of each one. It also clearly states that this is a base SD 1.5 model. You can see the publish date as well, which shows that it is quite old. At the top, you have the download button, and the file will go into the correct folder. In this case, it goes into the checkpoints folder. As I mentioned before, the author sometimes includes recommended settings. You can see them here. This is how I knew what settings to use in the K-sampler for the workflow. At the top, you also have a gallery with images generated using that model. This helps you understand what the model is capable of. Some images also have an info button that shows the prompt and settings used to generate that image. So, explore Civet AI if you have access to it, and see what models and LoRa's are available. Once you are signed in, you also get more options to control what type of models are visible, since some are disabled by default. So now that we played a little with that old SD 1.5 Juggernaut model, it is time to try a better, newer model to see how far AI has come in just 2 years. Let us go to Workflows again, and this time open the workflow named 5A, the one for ZImage Turbo with the all-in-one model. The workflow is quite similar to the others we tried. We just have two extra nodes this time. One of them is this conditioning node that we use instead of the one for the negative prompt, and the other one is this model sampling node. Since we are using a new model, we need to download it because we do not have it yet. The model is called Z-Image Turbo. Juggernaut and Z-Image Turbo are very different types of models, built with different goals in mind. Juggernaut is based on Stable Diffusion 1.5. It uses the classic diffusion architecture that has been used for years. The model file itself is relatively small, usually around 2 GB. Juggernaut was created by the community by fine-tuning and merging Stable Diffusion models. Z-Image Turbo is a newer type of model created by the Tongyi team from Alibaba. It uses a more modern architecture designed to generate images more efficiently. Even though Z-Image Turbo is much larger in file size, it is optimized to produce good results in very few steps. One important difference is how the models understand prompts. Juggernaut relies on the classic clip text encoder. It understands prompts if are short, but it often requires careful wording, sometimes keywords like prompts. Z-Image Turbo uses a more advanced text understanding system inspired by large language models. This allows it to understand prompts in a more semantic and natural way. Because of this, Z-Image Turbo can often follow instructions better, even with shorter or more loosely written prompts. So in simple terms, Juggernaut is smaller, very flexible, and highly compatible. Z-Image Turbo is a larger, newer model and smarter at understanding what you ask for. So we have here an all-in-one model, and there are two types, a smaller one FP8 and a bigger one BF16. It depends on your graphic card. If you can run the big one, use that one. For this first episode, I want to run it on a low V RAM card, so I will use the FP8 small version. All-in-one means it has everything it needs included. The clip and VAE model in this case, so we do not need to download those models separately. That is why it is easy to use for beginners. The models go into the checkpoints folder, and there we can create a special folder for the Z-Image model. Also, if you want to learn more about the model, I included an info link here, so click on it. Now we are on the Hugging Face page, and you can learn more about this specific version, from workflows to different model versions. If we go to Files, we can see different model versions that you can try depending on how good your graphic card is. So let us test the small version. Click here, then go to ComfyUI, go to Models, then Checkpoints, and create a folder called Z-Image so everything is more organized. Inside this folder, place the model. Since this is a big model, you need to wait for it to finish downloading. Because ComfyUI was open, you can see that it does not appear in the list yet, only Juggernaut. So I press the R key to refresh node definitions, and now we can see both models, nicely organized in folders. First is Juggernaut, and second is Z-Image. So let us select the Z-Image model. That is all for the model download, and now we can run the workflow. The first time you run a workflow, it is slower because it needs to load the model. The second time you run it, it should be faster. For me, it took about 10 seconds because I have a lot of ROM and VROM. The result looks pretty good compared to the robots we used to get with the SD 1.5 model. We have much nicer details. For the image size, I used a smaller size so it runs faster. This model was trained with bigger images, not like SD 1.5, so we can even use larger sizes like 1600 pixels if we want. Even if you go bigger than the size it was trained on, it does not produce many errors like SD 1.5 did. It just becomes a bit more diffused. Usually, for most newer models, a good place to start is around 1024 pixels. So let us say I try a landscape image this time, using these sizes. The result looks pretty good. I like it. Let us go back to workflows again and open the first workflow to see what is different and how we can recreate the Z-Image Turbo workflow. So we already have the right node to load the model in this case, so I just select the model from the list. For empty latent, this one is used more for older models with a different architecture. Many newer models use a different empty latent node. If we look at the nodes and search for empty, we have one empty latent and one empty SD3 latent. In this case, we want the one with SD3. On the surface, they look identical. It is just a different latent representation internally. If we make it purple, it looks like the previous one. If you do not have enough VRAM to run this, you can use sizes like 768 for width and height. I will use 1024 pixels since it is the most popular size and my system can handle it. So let us delete the old empty latent and now reconnect the new node. This model does not use a negative prompt, only a positive one, so I will remove the negative text. You can also collapse it if you want, that way you know not to add a negative prompt. Then we have the settings, which, as you remember, are different from model to model. If we look here, we only have 5 steps, so it can generate with fewer steps, and the CFG is 1. Let us change the steps to 5, and the CFG to 1. When the CFG is 1, it ignores the negative prompt. We also need a sampler and a scheduler. So let us add the DPM++ SDE sampler, and for the scheduler we use beta. Let us see what else is missing. We have this extra node called Model Sampling Auraflow. It has a long name, not sure why it cannot be something simpler, but anyway, let us search for that node. We change the shift to 3, and we make the connection go through that node, just like we did with LoRa. The Model Sampling Auraflow node is a special node that modifies the model sampling behavior before it goes into the K-sampler. It is designed to work with models that use the Auraflow sampling method, which is an advanced sampling technique used by some modern models for better stability and quality. What this node does is apply a sampling adjustment or patch to the model itself, so the sampler works in the best way for that model. The node takes the current model and a shift value as inputs, and outputs a modified version of the model with the Auraflow sampling logic applied. The shift parameter controls how strong that sampling adjustment is. Changing the shift value can subtly affect contrast, sharpness, and how the generation behaves internally. So we changed the empty latent to the SD3 version. We added a node to shift the model values, and we adjusted the settings to work better with the Z image model that we loaded in our workflow. Let us run it and see if it works. As you can see, it works just fine, and we get a nice robot. If we look at the previous Z-image workflow, you can see that it does not use a negative prompt, but instead it has a conditioning 0 out node. So let us go back to our workflow and search for that conditioning node. As I mentioned before, this model does not use a negative prompt, so you might wonder why we do not just delete the node. We could do that, but then we would have a missing input, and the workflow would throw an error. To fix this, we use the conditioning 0 out node. You can make space for it and place it between nodes if you want. This conditioning does not come from clip like the negative prompt did before. We connect it directly to the negative input on the K sampler. You can place it wherever you want to make the connections clearer, but I like to put it under the positive conditioning to save space. The conditioning 0 out node does exactly what its name suggests. It removes the influence of a conditioning input without breaking the workflow. In simple terms, it takes a conditioning signal, usually text conditioning, and replaces it with a neutral, zeroed version. So the model still runs normally, but that conditioning contributes nothing to the generation. Why this exists, and when it is used. In diffusion models, the sampler always expects both positive and negative conditioning inputs. If you want to remove or disable one side, you cannot just unplug it. That would break the workflow. Conditioning 0 out is a safe way to say, use conditioning, but make it have no effect. So if we run the workflow, everything works fine without any errors. Now, the good part about Z Image Turbo is that it is very good at realistic images, but it is also very good at understanding prompts. For example, if I want to create a portrait of a cat with a hat, I can easily get an image like this. But you can also create more complex prompts by using a large language model. Maybe you use ChatGPT, Gemini, or even a local LLM. I will use ChatGPT for this example. I ask it for a detailed photo prompt and give it the details of what I want. ChatGPT then gives me a long, detailed prompt that I can copy and paste directly into ComfyUI. So let us test it again. Now we get a different cat, but it is still a bit too simple. Let us make it more complex. I go back to ChatGPT and ask for the cat to hold a rose in her mouth and wear a t-shirt that says Pixa. Again, we get a long detailed prompt, and from that prompt we get this image. Sometimes the model can take things very literally, so you need to explain details clearly if you want more control. For example, you might need to mention that you want a full rose held horizontally in the mouth, and not something else. Let us create something different now. This time, a cartoon bunny, since this series is full of bunnies anyway. Again, we get a nice prompt, and the result looks like this. It is pretty cute. Maybe now I want the bunny to be a ninja. Let us see what this prompt generates. And we get our ninja bunny. If we generate again, we get another one. As you can see, compared to older models, the results with different seeds are quite similar. You do not get a huge variation from seed to seed. That is why I recommend using longer prompts and adjusting each prompt carefully. This model is very good at following instructions, so the more precise you are, the more control you get over the result. Let us open the first workflow again so we can compare it with workflow 5a. Now let us say I use the same long prompt and the same fixed seed for both workflows. If I generate with Z image, I get a robot like this one, which looks nice and detailed. Now if we try the old Juggernaut model using the same prompt and the same fixed seed, the result looks like this. It is smaller and much less detailed. Let us copy this image and paste it into this workflow so you can clearly see the difference in quality and also how well Z image follows the prompt. But maybe this single test is not enough to fully see the difference, so let us try something else. Let us test text generation. Newer models can generate readable text, but older models usually cannot. We normally put the text we want inside quotes, so let us test that. Look at this result. It looks very good, and it understood the assignment. Now let us go back to the Juggernaut model and use the same prompt. We get something like this. What is this? What does it even say? Gold Gola or something like that. It clearly cannot do text. Let us go back to Z image and try another test. A red sphere on top of a green cube placed on a black car. We get this realistic result. Z image is more specialized in realism, but it can also do 3D, paintings, and other styles. Now let us see what Juggernaut does with the same prompt. It gets the red sphere since that was mentioned first, and then it gets lost and forgets what it needs to do next. So clearly, Z image is a very good model to have, and you will probably spend more time playing with this model. Still, keep an eye on new models because they keep getting smarter and better as they get more training. You have now seen how an all-in-one model works and how we load checkpoints. In the next chapter, we will use models that are split, where clip and VAE are loaded separately so we can have more control. Let us talk a little bit more about diffusion models. Open ComfyUI and then open Workflow 5a and also Workflow 5b so we can compare them. In the first workflow, Z image is loaded as an AIO model. AIO means all-in-one. You can see that we used a load checkpoint node to load that model. The checkpoint already contains the diffusion model, the text encoder, the VAE. Everything is bundled into a single file. Advantages: very easy to use, fewer nodes, less setup required. Good for quick testing and simple workflows. Disadvantages: less flexible, you cannot swap the text encoder, you cannot change the VAE, harder to customize or optimize. This format is designed for simplicity and convenience. Now let us check the second workflow, the 5b version. You can see that we have 3 nodes now instead of 1. We have the load diffusion model node that loads the main model. Then we have the clip load node that loads the text encoder. And then we have the load VAE node that loads the VAE. So it is like we split the previous checkpoint into separate pieces, and now we have more flexibility. Even though the final result is still Z image turbo, the pipeline is modular. Advantages: more control. You can change the text encoder and experiment with different VAEs. Better for advanced workflows and optimization, and easier to update individual components. Disadvantages: more complex setup, more nodes, higher chance of misconfiguration if you do not fully understand what each part does. However, This is actually one of my favorite workflows. The reason is flexibility and efficiency. With a modular setup like this, you save disk space. For example, this VAE is the same VAE used by the Flux model, so if I already use Flux, I do not need to download the VAE again. With an all-in-one model, every new version means downloading the entire model again, even if only one part changed. In a modular setup, I can update or swap individual components. I can test different text encoders without downloading the main diffusion model again. So while modular workflows require more understanding, they are more efficient, more flexible, and better for experimentation. That is why I personally prefer this approach. But we did not download these models yet. I suggest that when you follow this tutorial, you test everything to see what is better or faster on your computer, and then keep only the ones you like. There is no point in keeping all types of models if they do the same thing, unless you have a lot of space on your hard disk. So let us start with the main diffusion model. This long name is actually describing how the model is built and optimized. Z-Image Turbo. This is the model family and architecture. FP8. This means the model uses 8 bits floating point precision. FP8 models use much less memory than FP16. I did not include a link in this tutorial for the FP16 version, but you can find those online if you have more VRAM and want to try them. Scaled refers to the FP8 format being calibrated for better precision. This improves quality and stability compared to a raw, unscaled FP8 format. You can think of it as FP8 with tuning for better accuracy. E5M2. This is the specific FP8 encoding variant used. KJ. It is usually a variant tag or builder ID added by the person or team that exported or repackaged the model. It does not change the model itself, it just helps distinguish between different builds. Safe tensors. This is the file format. Safe tensors is a safe and efficient format and is recommended over older formats like CKPT for better stability and speed. We can download this model from here, and I also added more info about the model so you can check different versions. You can also see the author, so now you know what that KJ in the model name stands for. So let us click here and see where we place it. Navigate to the ComfyUI models folder. You should already know this by now. This time we do not use the checkpoints folder, because that is usually for complete models that already include most of what they need. Instead, we place this one in the diffusion models folder. To keep things organized, we create a folder called Z-Image and place the model inside. Next, we have the text encoder. I used one recommended by ASD from the Discord server, but there are other text encoders you can try, made by different people. For this one, we again go to the models folder, and this time we place it in the text encoders folder. Here, I do not create a Z-Image subfolder, because many text encoders work with multiple models. I usually create subfolders only for main models, LoRa, and ControlNet, when it is important for the workflow that they match the same base model. Then we have the VAE. This is the same VAE that we might also use later for the Flux model. So again, we go to the models folder, and this time we place it in the VAE folder. Some of these models are large, so wait for them to finish downloading. Once everything is done, press the R key to refresh the node definitions. Now let us check that all models are visible and selected correctly. The Z-Image diffusion model is here, the clip text encoder is here, and the VAE is also here. That means we have everything we need to run this workflow. So let us click Run and see if we get any errors. Everything works fine and we get this image. What I usually do next is compare the results with the first workflow. When I have multiple models available, I download all of them, test them, keep the ones I like the most, and delete the rest. When I do testing, it can get confusing which model generated which image, so here's a small trick. Double-click on the canvas, search for iTools Add, and select the node called iTools Add Text Overlay. This node comes with Easy Installer, but if you have a different ComfyUI version, you can install the iTools nodes from the manager. We add this node right after VAE decode and before the Save Image node. This way, the final image goes through this node, the text overlay is added, and then the image is saved to disk. For example, we can add the model type in the text overlay. You can also add more text like the model name or other info. Let us say I add FP8 scaled diffusion, so I know this image comes from this workflow. Now when I run it, text will be added on top of the image. We can control the text, the background color, the font size, and whether the text overlays the image or is placed under it. Let us disable overlay mode and try again. Now the text is under the image. This way, we know exactly which model generated it. Next, I select this node and press Ctrl+C to copy it. Then I go to the first workflow and press Ctrl+V to paste it. Now we connect the node the same way as before. We need a name that represents this model. So let us name this one FP8 All-in-One. Now I can test it, and you can see the text under the image. To make a fair comparison, we use the same settings for both workflows. Let us also enable the bottom panel to see how much time it takes to generate. As you remember, the first time you run a model, it is slower because it loads the model. We can unload the models using this button and clear the cache using this one. This lets us compare which model loads faster and which one generates faster. I run it once, and you can see the first run took around 8 seconds. The second and third runs are faster, around 3.57 seconds. Now let us go to the second workflow. I unload the models and clear the cache, then run it again a few times. This one loads slower, but the second and third runs are faster. On my older PC, the all-in-one model was faster, so it really depends on your system. Test it yourself and see what works best for you. Now let us look at quality. We use a fixed seed with a value of 50 and run the workflow. Then we do the same for the first workflow, same fixed seed, and run it.